Okay, we're going to talk about analysis of graphs of functions today, graphs of basic functions and relations, and symmetry. A function is continuous over an interval of its domain if its hand drawing graph over that interval can be sketched without lifting the pencil from the paper. So it would be continuous if I can draw the graph maybe from left to right and continue doing that without lifting my hand. So in this example, if a function is not continuous at the point, then it may have a point of discontinuity, or it may have a vertical asymptote. We're going to talk about vertical asymptote in more detail later, but if you look at the first function, if I go from left to right, the function all the way from negative infinity to right at the point 2, the function is going down, and right at the point 2 I have to lift my hand to continue with this graph. So at point x equal to 2, this function is discontinued. And if you look at the next one, this graph from left to right going up, and right at this line here called asymptote. Asymptote would be the lines that your graph gets closer and closer to that but never reaches that. So right at that point x equal to 2 again, we're seeing that discontinuity appears, but all other points would be continuous. So if you look at this graph, it's a graph of parabola. It's a function, and as you can see from left to right, this graph would be continuous. The domain of this function would be all the way from negative infinity to positive infinity. This parabola is going to get wider and wider as you go to the right and left of that. So that, as you can see, the domain would be all the way from negative infinity to positive infinity, going to cover all the numbers from negative infinity to 0, and then from 0 to positive infinity. So that's how you write the interval for the domain. The range, however, we're going to talk about range later, would be all the way from 0 to infinity. That would be the value of y. But for the domain, pretty much going to cover all the numbers to the right of 0 as it gets wider and wider, and all the numbers to the left of 0 as this parabola or function gets wider and wider. So in this example here, the graph from left to right, from all the way, the domain would be from negative infinity all the way to 0. That would be the domain. But right at the point 0 is a discontinuity there. So there's no value for x for that, correspond to y. So if you want to write the domain of this function, you would write all the values from negative infinity to 3, and then right at point 3 to positive infinity. We are not going to include 3, so we are not going to use brackets. We're going to use parentheses instead to show the domain of this function. So it would be all the number from negative infinity to 3. We use parentheses. Right at the point 3 is this continuity there. So all the way from 3 again to positive infinity would be the rest of the domain. So this graph here, we have an asymptote at this line here at point -2. So the function from negative infinity to -2 would be a domain. The asymptote is the line x equal to -2. So all the way from negative infinity, and we use parentheses for point -2 because the -2 is not included. And then all the way from -2 to positive infinity would be your domain. The range value increases from left to right when the function is increasing. The graph rises from left to right decreasing if you go from left to right going down, and constant would be if there's no change there. So to decide whether a function is increasing, decreasing, or constant, you want to ask yourself, what does a graph do as x goes from left to right? So if you go from left to right, if going down would be decreasing, going up would be increasing. So if you look at this example here, the first example is increasing. If I pick 2 points on the graph, x1 and x2, and if I evaluate f of x1 and f of x2 as x1 is less than x2, if f of x1 also is less than f of x2, it means the function is increasing. From left to right, the function going up. That would be a condition for if the function is increasing. Similarly, if you pick 2 points, x1 and x2, if x1 is less than x2, and evaluate f of x1 and f of x2, if f of x1 is greater than f of x2, it means it looks like the function going down. So the function is decreasing. If f of x1 is equal to f of x2, no change there, so the function would be constant. So take a look at this graph here. We want to ask ourselves, what is happening to the y value as x is getting larger? If you go from left to right, you see the function from negative infinity to 0.1, the function is going down. All the way from negative infinity to right at 0.1. At 0.1 is a discontinuity, so the function is decreasing from negative infinity to 1. I'm not going to use brackets, I'm going to use parentheses because I'm not going to include 0.1, and that would be the values on the x-axis where the function is decreasing, going down from left to right. It's increasing from 0.1 to 3, and I'm going to include 0.1 and 3, that's why I'm using brackets there. So from 1, 3, this function is increasing, and both 0.1 and 3, as you can see, are included. All the way from 3 to infinity, there's no change there. So including 3 all the way to positive infinity, this function would be constant. Constant function would be like f of x equal to b. As you can see, the domain would be all the way from negative infinity to positive infinity, and you can also confirm this result using your calculator, and the range would be only one value, b. It's not going up or down. Right at point b, that would be the range. And the domain would be all the numbers from negative infinity to positive infinity. All these are included. And if you take a look at the graph using your calculator, let's say y is equal to b is equal to 5. So y is equal to 5. That would be the equation of this line. As you can see, regardless of what you substitute for x, y would be always equal to 5. And that means all those points are next to each other. So y is equal to 5 is really the same as y is equal to 5 plus 0x. The reason x is not there because its coefficient is equal to 0. So it doesn't matter what I substitute for x. When you multiply it by its coefficient 0, that turns out to be equal to 0. Any number times 0 is equal to 0. So I can also confirm that using the values we got on our calculator. Doesn't matter what I substitute for x, y would be always equal to 5. So that would correspond to all the points right next to each other. So that corresponds to the horizontal line, or that the constant function. As you can see, the domain would be all the value from negative infinity to positive infinity. So the next one is f of x equal to x, or we call this like y is equal to x. So we can also use our graphing calculator to take a look at the graph. As you can see, the domain would be all the values from negative infinity to positive infinity. So as a range, this line is going to increases from both sides. You can see it's going to cover all the values of x. The domain would be all the number from negative infinity to positive infinity. Also, for the range would be the same. The range would be from negative infinity to positive infinity. And you can confirm that results using your calculator. As you can see, the function is keep going up from left to right. Squaring function, like f of x equal to x squared. Just like y is equal to x squared. It's a parabola. And as you can see, you can confirm that result using your graphing calculator. You see the domain would be all the number from negative infinity to positive infinity, and the range would be all the number from 0 to infinity. And we can look at some of those points on your graphing calculator. So f of x equal to x squared. As you can see, the domain would be negative infinity to positive infinity. Symmetry with respect to y-axis. If a function f is defined so that f of minus x equal to f of x for all x in its domain, then the graph of f is symmetry with respect to y-axis. You may want to write this in your summary sheet. If you calculate f of minus x when the f of x is given to you, and that turns out to be equal to f of x, then that is symmetry with respect to y-axis. Cubic function would be like f of x equal to x cubed, y is equal to x cubed. You can look at the graph of the function using your graphing calculator. As you can see, the domain would be all the values from negative infinity to positive infinity, and the range also would be the same, would be negative infinity to positive infinity. So f of x equal to x cubed, increasing an entire domain, symmetric with respect to the origin. If a function f is defined so that f of minus x equal to minus f of x, this would be another fact that you want to include in your summary sheet, then we conclude that this function f is symmetric with respect to the origin. Let's take a look at this example. If f of x equal to x to the power of 4 minus 3x to the power of 2 minus x, we want to see if it has a symmetric respect to y-axis, if it's true or not. And the second one, we want to see if second function has a symmetry respect to the origin. So for both of these, we need to evaluate f of minus x and refer back to our definition, see if it is symmetric respect to y-axis or the origin. So the first one, f of x is given to me as x to the power of 4 minus 3x to the power of 2 minus x. So if I evaluate f of minus x and find out that it turns out to be equal to f of x, then I conclude that has a symmetry with respect to which axis. So in this case, I need to calculate f of minus x. To find f of minus x, when f of x is given to me, I need to substitute for each x minus x. It's a good idea to place a parenthesis for each x, or 2x in this function, and substitute for each x minus x. It looks like the exponents is even for both. So minus x to the power 4 means minus 1 to the power of 4 times x to the power 4. Similarly, minus x to the power of 2 means minus 1 to the power of 2 times x to the power of 2. Because the exponents is even, when you multiply -1 by itself 4 times or 2 times, it turns out to be positive. So you can see we can get back our same function, f of minus x, as it turns out to be equal to f of x. So when that happens, we can say the graph has a symmetry respect to y-axis. We can confirm that result looking at the graph on our graphing calculator. You can see has like a mirror image of graph on y-axis, has a symmetry respect to y-axis. Second one, you have f of x equal to x cubed minus 4x. So we want to prove that f of minus x is equal to minus f of x to show this has a symmetry respect to origin. And to do that, we evaluate f of minus x. There are a couple of places we need to substitute for each x minus x, and we use parentheses. As you can see, minus x cubed means minus 1 to the power of 3, and then minus x would be multiplied by -4. That turns out to be positive 4x. And as you can see here, we get because the exponent is odd, that becomes minus 1x. So that would be minus 1x cubed plus 4x. If I factor a minus 1 out, you can see you get minus f of x. This proves that f of minus x is equal to f of minus f of x. And if you look at the graph, that also, using your graphing calculator, that confirmed that graph has a symmetry respect to the origin. Square root function, f of x is equal to square root of x. It's like if I have y is equal to square root of x. If you look at the graph, you can use your graphing calculator. You can see your function is increasing from 0 to infinity and start right from 0. So the domain would be all the value from 0 all the way to infinity. Cube root function, f of x equal to cube root of x. If you look at the graph, you use your graph on your graphing calculator. As you can see, the function increases all the way from negative infinity going up to positive infinity. The domain is from negative infinity to positive infinity. It's like I have y is equal to cube root of x. Range also would be from negative infinity to positive infinity. It is continuous over that entire domain as well. Absolute value of a function. F of x is equal to absolute value of x. So if I have absolute value of a number, like absolute value of 2. Absolute value of 2 is equal to 2. If I have evaluating absolute value of x equal to any number like 2, if you look at the number line, if you locate 2 on the number line, absolute value of 2 means how far number 2 is away from 0. So that corresponds to the distance. It would be 2 units. Distance would be always positive number. So absolute value of 2 means how far number 2 is away from 0. Like absolute value of minus 2 means locate number 2 on the number line and measure how far number 2 is from 0. Still would be 2 units. You see the distance always corresponds to the positive number. So therefore, absolute value of minus 2 also would be equal to 2. So we conclude that if if f of x equal to absolute value of x, if a is positive, if this a is positive number, the result would be the number itself. If x is equal to greater or equal to 0, f of x, absolute value of x would be equal to just x. That would be the case where what we have inside the absolute value sign is positive number, would be the number itself. Would be just x. So x is 2, so absolute value of 2 is equal to 2. However, if x is negative, if the value inside the absolute value is less than 0, then the answer would be opposite of that number. Opposite of -2 would be +2. Okay, so mathematically we show that if f of x equal to absolute value of x, if x is less than 0, then absolute value of x would be equal to minus x. Minus x would be where you have the opposite of the number. So I need to put the minus right here. So if x is less than 0, that would be opposite of that number. The absolute value function, f of x equal to absolute value of x. This is like y is equal to absolute value of x. You can use your graphing calculator to see the shape of the graph. You see the function from left to right decreases from -infinity to 0, increases from 0 to +infinity. Symmetric with respect to the x-axis, if replacing y with -y in an equation results in the same equation, then the graph would be symmetry with respect to the x-axis. You may want to write this fact also in your summary sheet. Function f is called even function if f of minus x equal to f of x for all x in the domain. Its graph is symmetry with respect to y-axis. So if the graph is symmetry with respect to y-axis, it's also called the function is even function. This is another fact you want to include in your summary sheet. This is how you can confirm if the function is even, if it's symmetry with respect to y-axis. A function f is called an odd function if f of minus x is equal to minus f of x. And if you recall, that was a symmetry with respect to the origin. So if you have a graph has a symmetry with respect to origin, we call that odd function. These are the examples. We're going to decide whether each function is even, odd, or neither. So the first one, we have f of x is equal to 8x to the power of 4 minus 3x to the power of 2. For all these, we need to evaluate f of minus x. See whether either is even or odd, whether they have a symmetry with respect to the which axis or origin. So in this case, we have f of x equal to x, 8x to the power of 4 minus 3x to the power of 2. I substitute for each x minus x, or two places there. Since the exponent is even, it turns out to be a positive, so we go back to the same function f of x. So f of minus x is equal to f of x in this case. So because f of minus x equal to f of x, for each x in the domain, the function is even. Next example, we have f of x is equal to 6x to the power of 3 minus 9x. We need to evaluate f of minus x. So f of x here is given to me as 6x to the power of 3 minus 9x. To find f of minus x, I'm going to replace for each x minus x. So this would be like I have 6 times minus 1 to the power of 3, x to the power of 3, minus 9 times minus 1 to the power of 1, and x to the power of 1. As you can see, the exponent is odd, so this turns out to be minus 1. Minus 1 times 6 would be minus 6 x cubed, and then here we have minus 9 times minus 1, that give me plus 9x. As you can see, if I factor a minus 1 here, I would get 6 x cubed, and then here I get minus 9x. If I distribute this, you can see I get minus 6x cubed plus 9x, what I have here. So this is my f of x right here. So that's the same as minus f of x. So here we are concluding that f of x is equal to minus f of x. And if you recall, that was a condition for odd function. So this is an odd function. Next one, your f of x is given to you as 3x squared plus 5x. This is your f of x. So I have my f of x here. I need to evaluate f of minus x. For each x, I'm going to substitute minus x. As you can see, the exponent is even, so this would becomes plus x, and this would becomes minus x times 5 is minus 5x, and we don't have neither of those conditions for the function being even or odd. F of x is not equal to minus f of x, and also f of minus x is not equal to f of x. So in this case, we're going to say is neither.